Hello everyone, my name is P. Lavanya, working as Assistant Professor in EC Department from Marri Laxman Reddy Institute of Technology and Management. Today we will discuss about integrated circuits and operational amplifiers. For the subject integrated circuit applications, the course outcomes are: after successful completion of the course, students will be able to learn, understand the basics of Op-Amps and ICs in analog and digital circuits, identify applications of operational amplifiers and IC timers, analyze A to D and D to A converters for accuracy and suitability, and implement digital systems using combinational logic ICs, apply sequential logic and memory for practical circuit design. Coming to the syllabus, in the module 1, integrated circuits and operational amplifiers. In this particular unit, we'll discuss about integrated circuits and types of integrated circuit complexity, chip size, and basic concepts of operational amplifiers. In this operational amplifiers, types of operational amplifiers, and characteristics of the operational amplifiers, and inverting and non-inverting amplifiers, adders, subtractors, and V2I converters, I2V converters, sample and hold circuits, and all. Coming to module 2, applications of Op-Amp and IC 555 timer and IC 565 timer. In this particular unit, applications of operational amplifiers like triangular and square wave generators and voltage regulators and filters, types of filters, and coming to IC 555 timer, introduction to IC 555 timer and stable and monostable multivibrators using IC 555 timer and phase lock loops and principle and description of individual blocks of IC 565. So in this particular unit, we'll learn about applications of operational amplifiers and about IC 555 timer. Coming to module 3, A to D and D to A converters. In this unit, the basic techniques of D to A converters and A to D converters we will learn, and types of converters like weighted resistor type, R to R ladder type, and coming to A to D converters, counter type, flash type, and successive approximation type, and single slope A to D converters. Coming to module 4, digital integrated circuits. In this particular unit, classification of integrated circuits and comparison of the various logic families and applications of the integrated circuits. We learn about encoders, priority encoders, multiplexers, demultiplexers, parity generators, checkers, and all. Coming to unit 5, sequential logic ICs and memories. In this particular unit, students will learn about commonly available ICs like 74XX and CMOS 40XX and series ICs, decode counters, shift registers, and memories, ROM, RAM, types of ROM, and RAM architecture, and all. This is all about the syllabus of integrated circuits and applications. Overview of this particular session is introduction to integrated circuits, types of ICs, and introduction to operational amplifiers, and characteristics and parameters of Op-Amps and applications of operational amplifiers. Introduction to integrated circuit. So integrated circuits, what is meant by integrated circuit? Simply we call integrated circuit as a IC. IC is a miniature electronic circuit in which active and passive components are such as transistor, resistor, and diodes, capacitors are fabricated on a single semiconductor chip, usually silicon. Need for ICs. What is the necessity for ICs? Reduce the circuit size and weight, improve the reliability and performance, lower manufacturing and maintenance costs, and enable high-speed electronic systems. And what are the advantages of ICs are compact size, high reliability, low power consumption, improve operating speed. This is all about the introduction to the integrated circuits. Next, classification of integrated circuits. Based upon the signal processing, integrated circuits are classified into analog ICs, digital ICs, and mixed ICs. Coming to analog ICs, these ICs process continuous signals. For example, operational amplifiers, voltage regulators, phase locker loops. Next, coming to digital ICs, these ICs process binary signals like zeros and ones. Examples for these digital ICs are logic gates, counters, and microprocessors, memory devices, and all. Coming to mixed ICs, these ICs handle both analog and digital ICs. For example, analog to digital converters, digital to analog converters, and communication ICs. This is about the classification of integrated circuits. Coming to introduction to operational amplifiers. So basically, amplifier is an electronic circuit which is used to amplify the weak signal. Introduction to operational amplifiers. Amplifier. Basically, amplifier is an electronic circuit which is used to amplify the weak signals or strengthen the weak signal. Coming to operational amplifiers means these amplifiers are used for some arithmetic operations like addition, subtraction, even for differentiation and integration. So operational amplifier is an electronic circuit which amplifies the difference of the input signals. So an operational amplifier is a high gain differential amplifier. Differential amplifier means which gives the difference of the inputs. Next, amplifies the difference between the two input signals. So basic symbol for these amplifiers are inverting input, non-inverting input, and output terminal. So the popular operational amplifier is IC741 Op-Amp. So this is the operational amplifier symbol. So here we have positive input terminal and negative input terminal. Here positive input terminal is called as non-inverting input terminal, and negative input terminal is called as a inverting input terminal. So operational amplifier is having 5 terminals. First one is non-inverting input terminal, second one is inverting input terminal, and we have output terminal here. Output. Next, here we have positive power supply and negative power supply. So positive power supply is plus VCC and the negative power supply is minus VE. This is the symbol for operational amplifier. So this operational amplifier is having 2 input terminals and 1 output terminal, non-inverting input terminal and inverting input terminal with power supplies plus VCC and minus VCC. Next, coming to the block diagram of operational amplifier. So operational amplifier is consisting of 4 blocks internally. So input stage, intermediate stage, level shifting stage, and the output stage. So for the input stage, we have 2 inputs, inverting input and non-inverting input. After that, input from the input stage, next is intermediate stage. After that, level shifting stage, and then output stage, we have output. So the total system comes under the operational amplifier, right? Next, block diagram for operation. The major stages of this block diagram, first one is differential amplifier stage. So this differential amplifier here, the input stage is differential amplifier stage. So the differential amplifier stage, it provides high input impedance. Second one is intermediate stage. So intermediate stage means here intermediate gain stage, it provides voltage amplification. And the third one is level shifting stage. So level shifting stage means it adjusts the DC level of the signal. Coming to the fourth stage, it is the output stage. Output stage means It provides low output impedance. This is the major stages of a operational amplifier block diagram. Operational amplifier main features are high gain amplifier, high input impedance, and it has low output impedance. So next, coming to the pin diagram of 741 operational amplifier. So 741 operational amplifier is a 8-pin op-amp. So here first pin is offset null, second pin is inverting terminal, third pin is non-inverting terminal, fourth pin is negative power supply, fifth is offset null, sixth pin is output, fourth pin is positive power supply, and eighth one is not connected. This is about the pin diagram of a 741 operational amplifier. So ideal characteristics of operational amplifier. So the ideal parameters of operational amplifier are infinite open loop gain, infinite input impedance, zero output impedance, infinite bandwidth, infinite slew rate, zero offset voltage, infinite common mode rejection ratio. So for practical operational amplifier also, approximately the parameters are same for practical operational amplifiers. Thank you for this session.